Hello, good morning. We are here to present our topic count district permutation of an array that sum to the target. I am Het Patel and my teammate Manav Patel will be joining me in this presentation. This project is our part of our data structure and algorithm course under the Department of Computer Science and Engineering, Charles University. So our problem statement. The problem the problem we given in the array integer and the target value. Find all distinct permutation of the array elements whose sum equals that target. Each unique permutation that satisfies the condition should be counted. It is a simple words we are finding how many different arrangement of number from the array can add exactly to the sum uh, target sum. Example. Let's take an example. Input array 1, 2, 3. Our target is find to target 4 possible permutation 1, 3, 3, 1, 2, 2. The count distinct permutation is 3. Key idea. We generate all the possible permutation of the array. For each permutation, we check if the sum equals to target. We used to set the hash structure to store only unique permutation. Finally, we return the total number of a valid permutation. Algorithm steps. There are 4 algorithm steps. Our first step is take input array and target value. Second step, use recursion or backtracking to generate permutation. Step 3. For each permutation, calculate the sum. If the sum equals the target, add it into the result set. Our 4 is return the size of the result set. If the sum equals to the target, add its result set. This ensures that every valid unique permutation is counted exactly once. This is a pseudocode of our problem. Function permutation array 1 result set target. If L equal to length array -1 -1. Here the pseudocode. This is the code and initialize result set calls or a helper function permute to generate permutation recursively and returns the number of unique valid result. For loop start from I from L to length array -1 swap array of L and array of I permit and store. Helper function handles the recursion and swapping elements whenever a full permutation is generated. We calculated its sum. If it matches the target, we insert it into the result set. This is the process repeat all possible permutation all possible permutation and using recursion or swapping makes the implementation both elegant and efficient. Thank you. And my friend Mano is the study about implementation of the code in C++. Thank you.
Thanks, Ed, for giving the overview of the problem statement. Let us now discuss the code implementation. Here we have take the function name permute, in which we have the arguments vector array. L means left index, R is the right index, and the target, and we have the result. We will check the condition. If L is equals to R, then we will use accumulate library function, which add up the total sum and it will returns the target which we have set. Then if sum equal to there, then we'll directly display the result. We have used the for loop. This for loop is start from I equals to L to I is lesser equal to R because it will check all the permutation and combinations of the sub arrays and it will total the sub arrays and it will throw the result. We have used swap for it will swap the index of I with the index of first, and then we have used permute for permute function for the checking next combination. Then we have used again swap function for rearranging the array. And now in main function we have just the input types. Here is the code explanation. It uses recursion and swapping to generate all permutation. As we discussed, the loop we have used is for recursion and swapping. We have also used the unique permutations are stored in vector in array. Accumulate function easily calculates the sum of elements as we discussed. Finally prints the total number of valid distinct permutations. Okay, let us now check the input and output. We have taken the target 4 and we have the array of 3 elements which is 1, 2 and 3. Okay, there are 3 permutations which sub arrays total will come the answer as 4. So it will throw the output as 3. We have another one example in which it will check all permutations and sums and it will reject the first and second because it is not getting the sum as answer 4. Okay, let us now discuss about the time complexity analysis. Here the time complexity for the permutation and checking combination is n factorial because it has to check all permutation and combination, and the space complexity is O of n because it is recursion stack space, and auxiliary space is O of k to store valid unique permutations. Here are the real life applications used in combinatorial and optimization problems, helpful in pathfinding and subset sum related algorithms, strength understanding of recursion and backtracking, demonstrate the use of hashing to avoid duplicates. Here are the key points. Based on recursion plus backtracking approach, uses set to remove duplicate permutation. Okay, I forgot to tell that we use swap function second time, which is the example of backtracking approach. Now it highlights the power of recursion and hashing together. Simple yet effective example for learning permutations. Thank you.